The name of our project is Snake Game. It is a part of our microprocessor and interfacing laboratory, course number 33316. The whole project is demonstrated by this is a group photo of the team members. Basic feature of Snake Game. A snake game is one of the most popular and simple games where a snake-like object moves in a confined display depending upon the direction set by the player. Whenever it eats a food, its length increases and the player gets some point. Whenever it touches its own body or hits the sidewall, it is annihilated and the game is over. Whenever it eats a 5 food, its difficulty level increases. With the increment of the difficulty level, the speed at which the snake travels increases. Algorithm. The total coding process of this game can be divided into 3 major categories. First, basic snake movement, that is up, down, left or right. Check limiting conditions, that is whether it is touching its own body or hitting the sidewall. Second, foot process and increment of length, difficulty level control. Third, display score and difficulty level, other accessories. Extra features that we have added in this project is a sound is produced each time the snake moves and each time it eats a food. There is a pause button which can hold the game at any stage. Whenever the start button is pressed, the game starts from where it was halted. Components. The components that we have used in this project can be divided into two basic categories, hardware and software. Hardware that we have used in this project are microcontroller ATmega32, microcontroller ATmega8, programmer, LCD display, 8x8 dot matrix, IC7805, buzzer, resistors, capacitors, switch. Software that we have used in this project are Microc for AVR for code compilation and building hex files, Proteus for simulating the hardware, Phoniproc for uploading the program into the micro. This is our Proteus simulation model that we have designed before going to design the PCB. And this is our printed circuit board design, which ultimately we have realized in the real time.
This is the final stage of our project. We are supposed to implement our project on a PCB board. We choose to design the PCB board on single layer basis, so all the copper connections is only one side of the board and the circuit components are the other side of this board. To implement this project, we used a 18x8 dot matrix on which snake moves, and to control these dot matrix we need a ATmega32 microcontroller. There is the LCD display on which a score shows the scores, and it also preserves the best scores, and to do so we have to use a EEPROM here. This is the ATmega8 microcontroller that controls this LCD monitor. There is the buzzer, and this is the power supply circuitry where we use a 7805 IC that ensures the 5V DC supply, constant DC supply. And there are 6 switches that controls the movement of snake. The start button, a pause button, and 4 buttons to move the snake in 4 directions. There is also a port in the circuit and that controls the intensity of the LCD display. This is the major components of the total project. Now we are going to show the live demonstration of the game. Here we pressing the start button. The snake moves and the food generated. After each consumption of food, the scores increases by 5. Here you see, and it also shows the best score. In the game, the food has been generated randomly to ensure that the food would not generate it in the same position or on the body of the snake. Now you see in the LCD that when the scores move from 20 to 25, the level increases to 2, and at the same time the speed of the snake has been increased significantly. So after each increase of the level, the speed of the snake will increase. There are 2 options to finish the game. The game will crash if the snake touches itself or if it crashes in the wall. Now you see that the snake crashes the wall and the game finishes. At the same time, in the LCD the score is preserved for 5 seconds and then it reset. Now we are going to show the second option of finishing the game. As the snake touches its own body, the game finishes.
The special feature of our game is the buzzer. When the snake moves, it beeps, and when the snake eats food, it beeps 2 consecutive times. When snake crashes, the buzzer beeps for a long time and the cross sign is displayed dot matrix.
Here you see the best score is 10 in the LCD, and the best score is preserved in EEPROM. Now after each consumption of the food, the scores increases by 5. And now we see the best score is increases to 15. We have used an EEPROM in the LCD to preserve the best scores, and now you can see in the LCD that the best score is in 85. Now if the game finishes, and we restart the game, even if the main switch is turned off and we again turn on it, we can see that the best score is preserved in 85. That's the function of the EEPROM in our game. And there is also another feature in this game which is probably the most interesting feature, and that is the pause feature. Now we can see when we press the pause button, the game pauses. It will again continue if we press the start button, as we see here.
We are going to discuss about some of the difficulties that we faced. One of the major difficulty was the pin configuration of the dot matrix. In simulation it has a very symmetric pin configuration, but in real life experience all of the pins has to be determined with the multimeter. Now we are going to discuss about some of the positive effects of our project. One major advantage was that everything, the dot matrix, the LCD and 2 microcontrollers are separately soldered on the serial rails. So if anything does not work properly, we can just change it and still the total circuit works well. Another major advantage is that the 2 microcontrollers act separately. One microcontroller for the LCD and another one for the dot matrix. If any fault occurs on the dot matrix, or it may just consume high current, or if any short circuit occurs, the LCD circuit will not be affected by this. So this is relatively easy to debug and easy to change.
And thanks to our course teachers, Imran sir and Sajid sir, for their valuable advices.